So, what can you separate this into?
The integral from 0 to 1.
Well, first, hold on. Let's just do this first. So it's x e to the x times 1 over y dy dx, right?
Yeah.
And you can change that into the integral from 0 to 1 of x e to the x dx times the integral from 1 to 2 of y to the negative 1 dy.
So this is what I use tabular on.
Okay, well for this one right here, what's the easier one? The right, this one or... Yes, okay, there are many different ways. Let's just do it this way first. If we want to integrate this, what does it turn into? ln y from, that's going to be ln 2 minus ln 1, which is 0. So this is just what? ln 2. Great. So then for this one, if you had to explain this to an AP Calc test, oh wow, how would you go about doing this? What would you do first? Yes?
Do we do it in parts?
I understand the method. I understand the name. Tell me what I would specifically do first. Like what would I actually write down on this?
One is u, one is v.
Set.
X equals u.
So okay, so u is equal to what? X. Now what? So du is equal to what? Dx. So now what do I do? Dv is equal to e to the x. So therefore v is equal to what? E to the x. Now you rewrite this, correct? So what do I rewrite it as, Shuhan?
So, the integral of dv.
You forgot dv.
No, I did write dv. So she said this is dv, right?
No, dx.
Oh, yeah.
Thank you. Like that? Good. Okay, so now what?
So, integral of
U dv, yep.
equals to uv.
Hold on a second, I want to pause this. What are my limits of integration? What are the limits of integration that are missing?
0 to 1.
It's from 0 to 1. So it's going to be x e to the x minus e to the x from 0 to 1. So what's this going to be? Minus what?
Minus e.
Minus e. Correct. So I guess my question is, how did you, now that you this will hopefully shake a few things around in your mind. Shuhan, how did you go about choosing u equals x, du equals dx? How did you go about choosing u equals x and v is equal to e to the x?
When it is easier to do the integral of v, then I choose.
Yeah, you want to be able to integrate v, right? You want to be able to integrate v because you're doing v, yeah, v du right there, yeah. You're integrating v. So you want to be able to break it apart, and also you know that the product of the two has to be whatever's on the inside here. So yeah, you do it out, you fill in the definition, and the only thing we missed when we were doing this was these limits right here. Absolutely. Totally agree. Okay.
You square 1.
You square 1, and what do you get?
1.
This is really important. Do the limits of integration frequently change when you substitute? You have to be really careful. Really, really careful.
You show when you lost me there.
Which part did I lose you on?
When they change.
These are limits of integration. Those are y values, correct?
Correct.
When you plug in 0 into that, what do you get? What's 0 squared?
0.
What's 1 squared?
1.
So therefore, do the limits of integration change? These are now u values.
So if u equals y squared
Plus
1,
17.
then it would change.
Yes.
Okay.
But in this case, when you square 0 and you square 1, you end up with the same thing.
I was confused about how you would figure out.
Yeah.
what it would change.
So you have xy over the square root of x squared plus u squared plus 1. And it... u, thank you, plus... times du over. You remember when you do u substitution, you're praying, you're hoping, your goal is to get rid of something, right? You're trying to cancel out. In this case, what are you trying to cancel out? Yay! Is that exactly what you want? Yeah, what can you bring out to the out? Oh, I'm going to make this 1/2, 0 to 1, 0 to 1 of x.
Can x come out too, because it's a constant?
We can do it. Where can we pull x out to?
To the middle.
To the middle. So we can, that's fine. What do you get? 1 over the square root of x squared plus 1 du. Okay, I'm okay with this. du dx. Thank you. Thank you. Yes. So now what did you do, Shuhan?
I substitute y back. Oh, wait.
How about we just try to integrate now?
Yeah,
Can't we just try to integrate this now directly? So if we try to integrate this directly, we end up with this going from 0 to 1 of x times. What's the what are we going to try to get here?
Well, you can put that thing at the top to the negative 1/2, and then use the
Yeah, so it's x squared plus u plus 1, right? And it's going to be to the what power?
negative 1/2.
We're integrating it, right? So it has to go to the 1/2, right?
I thought you were
You drop the 1/2 to the front, but we don't want it to be there, so what do we have to plug out here? A 2, right? And then it only kicks out a 1 when you use the chain because the derivative of u is going to be 1. And what's that going from and to? 0 to 1. It's still 0 to 1. That's correct. And there's a dx on the outside. Yes, absolutely. Absolutely. So now we need to evaluate this. Now when we take these values, where do we plug them in? For what?
U.
For u, exactly. So we end up with 1/2 0 to 1 of x times 2 times x squared plus 2 to the what power?
1/2.
Minus 2 times x squared plus 1 to the 1/2, and we close this in its dx. What can we factor out to the outside of this thing? 2. The 2's and the 1/2 cancel, yeah. So what do we end up with? 0 to 1 of x times, and I'll do the brackets again, sorry. X squared plus 2 to the 1/2 minus x squared plus 1 to the...
You could just put that all in one.
So, are we okay with that? What do we think?